Okay, so the next problem in the lead code we are solving is top k frequent elements. Okay, so now let's try to understand what does this even problem means, right? Okay, so basically here they have given us a list of numbers. Okay, 1 1 2 2 3 3, and we are being asked top k frequent elements, and they have given us a k is equal to 2. Okay, it is, so the problem sounds like top 2 frequent elements. Okay, so what does it mean is frequent so how often the element is occurring in a given list. Okay, that's what the frequent element meaning. Okay, so if you check the frequency, one has occurred for thrice, and two has occurred for let me change the thickness. Yeah, two has occurred for twice, and three has occurred for once, right? So this is the frequency. Okay, now they asked for a top two frequent elements. So obviously this will be the answer. We need to return one and two, right? This is a straightforward thing. Let's say if they ask for top one frequent element, right, we'll have to return only one. Top three frequent elements, we'll have to return all the three numbers. Okay, and also we can return in any order. Order doesn't matter. That's what is begin given here. Okay, so now let's see that how we can solve this. Okay, now before even directly jumping to the one efficient approach, right, we'll see like how this normally can be analyzed and solve it. Okay, so basically if I want to find out a top k frequent element, right, for obvious first thing is we need to identify a frequency, correct? So I will write the frequency in other way around. Okay, let me say 3 has occurred for once. Okay, and let's say that one, how many times one has occurred for thrice. Actually the distinct numbers are, so basically 3 1 and 2, right? There are three elements available. I'm just doing that. Okay, one has occurred for thrice, 1 2 3, and two has occurred for twice. Okay, this is the frequency available in the given array. Okay, so now we need to identify top k frequent elements, right? But this is, you can see, right, we can see it is in jumbled order. We cannot directly say one is one and three, these three are the frequent element, right? So to identify it, what we can do is we'll have to sort it, correct? We'll sort it based on this value, correct? Once we sort it, obviously let's say that once I sort, how it will look, it will look like, I will just write it here. Okay, one has occurred for thrice, and two has occurred for twice, and three has occurred for once, right? After sorting based on that, we got this mapping, correct? So automatically they was for top two frequent elements, I can just pick these two, correct? So I'm done with this, correct? So whatever the based on after sorting, I get this answer. Okay, so now let's check the approach and we'll see like what is the problem here. Okay, like we cannot how this can be improved or so. Okay, so basically now the first step is we'll calculate the frequency. Okay, and I've used the default dict here because I don't want to especially handle like get, check if the number exists, if it doesn't exist give zero, all these things, right? I don't want to do this, so I have used the default dict here. So that's what it will do is, as I said, the data type of the dictionary will be integer. It will automatically give me a zero if it doesn't exist. Frequency of num, if it doesn't exist, it will be 0. Okay, I will be just incrementing it to 1. Like if it is for the first time, it will set it to 1. Okay, so that's why I use the default rate. I've calculated a frequency, and then here I have sorted based on the value. Here we need to sort it based on the value, right? That's what we are doing here. Okay, so basically to just explain this here, right, we are using a sorted function here. We are giving both key and value to this function. So basically it will be like 3 comma 1 and 1 comma 3 and 2 comma 2. Okay, this is the input for the sorted function, and we are telling to use this as a parameter to sort it to value. Okay, item, it will get an item, it will for each of this item we'll have a tuple, right? 0 comma 1. So we are asking it to use this guy to sort it. Once we sort it, and also we need a top two, right? I can just you can either sort it and then pick the last minus n element, right? We can do it, or what I am planning here is reverse is equal to true, so sort it in this order. So I will just pick the first two element, first k element. Okay, so that's what we are doing. Okay, this is about sorting. Once the sorting is done, we can just pick the first k elements. Okay, and we are going to pick the key here. We don't, but this tuple has a key comma value, right? Key comma value, like I mean the number occurred how many times. Okay, this is the tuple. We want only the numbers, right? We are interested only in that, so that's why we are picking the 0 here. Okay, so this is how we can solve it. Okay, this is one way of solving. And also here, right, so basically what has happened here is we got the frequencies and we are sorting it. Okay, now let's say that there are only three elements. It is very simple. Okay, now let's say that hundreds of elements are there, or maybe thousands of elements are there in the list, and it has been asked to find out only top two. Okay, so but still what we are going to do here is we are going to sort all the 100 elements, and we are going to pick the first two elements, or maybe like all the 1,000 elements, and maybe we'll pick the first two elements, right? What like, I mean, whatever the time that was spent in sorting these elements, right, it's a waste of time, right? We don't need those elements, but we still sort it, right? That's why sorting will add some unwanted time complexity, and now we need a way to reduce this. Okay, we don't want that. Let's see that how we can achieve this. Okay, before actually maybe we can use an heap here data structure to solve this. Okay, before actually trying to understand this, right, I would like to give some brief overview how this heap data structure works. Okay, if you are already aware of how this heap works, you can just skip this portion of lecture. Okay, so basically here what we are trying to do here is, let me pick a pen. I'm going to explain what is the CP in a quick, like a brief way. It's better to have a good understanding before you actually even approach the problem. I'm just like revising for it. Okay, so basically heap is a tree data structure. Okay, you can just see it here. It's a tree data structure, and so basically there are min heap and max heap. There are two types of data structure. I mean, if you classify heap as two, right, min heap and max heap, what does it mean? So heap, like, I mean, whatever the number, right, let's say that ultimately you can represent these numbers in a list, right? Let's say that 1 2 3 4 5 6, correct? But if it is in heap, it will actually take a different format of representing it. Okay, you can represent this whole tree in a list, right? That's also true. Okay, but here in the case of min heap, right, what does it mean is, so all the time, let's say that it will always have the, let's say that if it has 100 elements, right, it will have the whatever the out of 100 value, it will have the least value in the root. Okay, in the case of max heap, it will also same. It will, let's say that if it has 100 elements, it will have the maximum element in the top element. Okay, this is one thing. Okay, so actually okay, we can simplify it as like, in the min heap, right, always the parent element will be the lowest of the child elements. Okay, you see that one is lesser than 3 2. In the max heap, the parent node will always be greater than the child elements. Okay, this is a simple definition that we can give it for a mini heap and max heap. Okay, and now, okay, how does it helpful here, right? So basically, ideally, like usually heap, right, heap will be used for priority queues. Okay, so basically, let's say that we have a task like 1 to 100. Okay, 1 to 100, it has some weightages. We need to do always whatever the order or whatever it, right, we need to do this, execute this task first, and later after all the tasks we need to execute under 10, right? So in this case, let's say that I'm going to use a main heap. I am going to push all these tasks to the heap. Okay, so let's say that currently we have six tasks. It has been shown here. Okay, let me clear this out 1 second. Sorry for the disturbance. Clear all drawings. Okay, so now right now we are taking an example of minimum heap. So what I'm going to do here is we are going to push all the six tasks to the heap. Okay, so now I can just say I wanted the next task available. I will just say pop. Okay, once you say pop, the minimum whatever that is present, right, it will come out and it will execute it. Okay, and once you execute it, it will get automatically balanced out. Okay, which is the next minimum element? It will be 2. Okay, and next will be 3 will come here, maybe 3 will come here, 4 will come here. It's been some time balancing it, but please excuse me with respect to that. And let's say that I will go say 5 is here or 6 is here. Okay, this will be after balancing. Okay, 1 is done. Now 2 will automatically come and sit here. Okay, next time what will happen? Next time if I want to execute next task, it will come go out. Next 3 will come and sit here. Okay, this is how the min heap or max heap work. So basically, whenever you pop, you are going to get a minimum element. Whenever in the max heap, whenever you're going to pop, you are going to get a maximum element. This is the easiest definition one can recollect. Okay, so now let me clear it out again. So now let's try to understand how is this helpful for us, right, to solve this problem. So basically, in this problem, we need to avoid all the multiple we need to avoid the unwanted sorting, correct? So what we'll do is we'll set the heap size. Okay, let's say that we want a top k elements, right? For this example, I will say top 2 elements. We need a top 2 elements only. We don't need all these things. Okay, so what we can say is heap size is k. Okay, we need only top 2 elements, so I will set it heap size as k. Okay, so now let's take an example. Okay, let's say that one, I have a list of numbers. Okay, these are the frequencies basically. Okay, I'm going to store it as a frequency 1 5 10. Okay, now if I put it in a mini heap, how it will look? One, and here what it will be? 10, right? Yeah, 10, I guess. So we don't need to worry about the structure for now. 1, 10, 5. Okay, so now what did we say? K is equal to 2 or 3. Okay, let's take it as a 3. Okay, as I write the 3 there, K is equal to 3. I'm going to initialize the heap size as 3. Okay, so now let's say that I'm going to get a new frequency. Okay, when I'm just iterating through the whatever the frequency that we calculated, right? Instead of sorting, I'm just going one by one. Okay, I'm checking the frequency. Now the next frequency is 15. Okay, so now I will add it to here. Okay, if I add it here, so automatically it will go down till here, right? It will automatically go down till here. And now I know that I want only the 3 elements, but my heap data structure is now having the 4 elements. So I will just apply pop. Okay, so now what will happen? Obviously the minimum element that is present, this as is a minimum heap, it will go outside. Okay, so now after restructuring, how it will look, 5 will come here, and maybe 10, I think he'll go here, and 15 will come here. Okay, so now automatically K is equal to 3. Now 1 is removed. Now you can just visualize it from here, right? If I ask you top 3 elements, top K 3 elements, obviously you'll pick these 3, correct? Obviously this 1 is eliminated. So just that that's what is happening here. So we are going to maintain heap of K size, and whenever we add an element, and we'll keep a track of the heap size, we don't want more than K elements. That's why we'll apply pop. Automatically we what the task or the weight, that frequency that we don't need, it got eliminated. Okay, so that's why we are going to use an heap data structure here basically. So we are going to avoid the sort now. So basically we'll be just iterating through the frequencies, and we are going to add it. If it is crossing the heap size, we'll say pop the element unwanted, and it will pop the least elements, and automatically it will always keep a track of it. Okay, now let me take in one more example, 5, 10, 15. Correct. Now let's say there is one more frequency that came in. Let's say what, 3. Okay, so there is one element that has occurred thrice. So let's say that even though I put it inside, right, now the heap size will become 4. Heap size will become 4. When I apply pop, automatically this will be the first element that's going to go removed, correct? Because these are highest. I mean, this is the least. This will be at the root node, that will be get removed. Okay, so that's how this heap is going to use will come into our use case. Okay, now let's see the implementation, that will be more clear. So one takeaway from here is, actually, like whenever the problem is about top K frequent elements, or top maybe less frequent elements, or top K frequent element, right? Top K less frequent element, all these things question, right? We can go with a heap data structure. And one difference is here, we are being asked here is multiple elements. So we are going to set it as K. K is equal to some numbers. Okay, so once we got it, we are going to convert it to list, and get return it as a result. Whatever the result we have, right, we are going to return it. Let's say if the K is equal to 1, or let's say the top K frequent element, or top this, right, in that case K will be equal to only 1, right? That is the only difference. Okay, so now let's see the implementation, it will be more clear actually. So here, right, so basically let me take the marker. Okay, so first thing, as we said, we'll calculate the frequencies, and we already explained why the default stuff and all. And finally here, heap is then nothing but a list, as I said, right? We are going to just represent, we can represent this binary tree in the form of list, right? We are going to say this guy, and we'll push the element. Okay, and also while explaining, I talked only terms of the count, but we need to mapping for number also, because let's say that after later, right, as a result we got to know that what was it, 5, 10, and 15 are the frequencies, highest frequencies. But we don't want to return the frequencies, we want to know which are those elements that has that many frequencies, correct? So that's why when you push the heap, push the count command, and make sure keep the count in the beginning, because this is what is the parameter that is considered to sort the first element. Okay, so that will be the first element. So you push the count command, and the heap data structure is built in such a way that, okay, and whenever you got a new element, you will push it. And let's say that if it is crossing those many elements, right, we'll just pop the element. We are automatically removing the least frequent elements. Okay, automatically removing it. Once it is everything is done, frequency is iterated, and we'll come back, and whatever the elements that are present in the heap, right, we are going to extract the numbers. Okay, because count comma num is there, we are going to extract the number, and finally we'll return the result. We'll prepare a list and we'll return it. Okay, this is it actually. So to summarize, every time whenever you run into problem like top K frequent element, top K least frequent maybe, or top K frequent element, or top K least frequent element, all these things, right, we can just go with a heap data structure to avoid sorting and to save some time. Yeah, that's it. Thanks.